Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into the fascinating world of the Web Audio API and how to create variable duty cycle square waves. This is especially relevant if you're into recreating those classic 8-bit Game Boy sounds.
Oh, Game Boy Audio. That's awesome. So what's the big deal with square waves and duty cycles anyway?
Well, the iconic chiptune sound relies heavily on square waves. The problem is, the Web Audio API's built-in square wave oscillator only gives you a 50% duty cycle. That means the wave is high for half the time and low for the other half. The Game Boy, however, allowed for variable duty cycles, like 12.5%, 25%, 50%, and 75%. This is key to getting those rich, textured sounds.
Ah, I see. So the standard square wave isn't enough. What are our options for getting around this limitation?
The article outlines two main approaches. The first is using the Fourier series. Basically, it's a way to represent any periodic waveform as a sum of sines and cosines. Think of it like building waves from harmonics, like Lego bricks.
Fourier series. That sounds a bit math-heavy. How does that translate into code?
It involves calculating Fourier coefficients and then using the create periodic wave function in the Web Audio API to create a custom waveform. You essentially define the real and imaginary parts of the coefficients to shape the wave. The more harmonics you use, the more accurate your square wave will be.
Okay, I think I'm following. So more harmonics equals a better square wave, but at what cost?
Exactly. The downside is that it can be quite CPU intensive, especially if you're calculating the curve on the fly for arbitrary duty cycles. But if you only need a few specific duty cycles, like in this Game Boy Music Tracker project, you can pre-compute the curves and reuse them.
Got it. So what's the second approach? Is it less mathy?
Yes. The second approach uses a wave shaper node. This node lets you distort audio signals. The trick here is to start with a sawtooth wave and then use the wave shaper node to bend it into a square wave with the desired duty cycle.
Bend a sawtooth wave? How does that work?
You create a step function that essentially clips the sawtooth wave. If the value of the sawtooth wave is below a certain threshold determined by the duty cycle, you set the output to 1. Otherwise, you set it to -1. This creates the sharp transitions of a square wave.
That sounds much more intuitive. So you're basically using the wave shaper node as a fancy on/off switch?
Pretty much. It's a clever way to get a square wave with a variable duty cycle. The author of the article mentions that they prefer this approach because it's simpler to grasp.
But there's always a catch, right? What are the downsides of the wave shaper node approach?
You're right. The main issue is aliasing and buzziness. Because the wave shaper node creates almost perfect square waves with extremely sharp transitions, you can get unwanted high-frequency artifacts.
Ah, so it's a trade-off between CPU usage and audio quality. Which approach does the author prefer for their Game Boy Music Tracker?
They prefer the wave shaper node approach. They like the simplicity and believe it creates a more authentic Game Boy sound, even with the buzziness. Plus, since they only need 4 duty cycles, they can pre-compute the wave shaper curves to optimize performance.
Interesting. So it really depends on the specific use case and the desired sound. It sounds like the wave shaper approach is more authentic to the original Game Boy sound, even if it's not technically perfect.
Exactly. And that's the beauty of it. The Web Audio API gives you the flexibility to choose the right tool for the job. The author encourages more developers to explore the Web Audio API and see what cool things they can build with it.
Definitely. It sounds like a powerful tool for creating all sorts of interesting audio effects and instruments in the browser.
Absolutely. Well, that wraps up our discussion on creating variable duty cycle square waves with the Web Audio API. Thanks for tuning in to Tech Bytes and News. We'll catch you next time.
Bye-bye.